Today we'll be working on the following problem. Let X and mu be a measure space, and there is a sequence of measurable set E sub n. So we want to ask, are the following two statements always true or not? First one is the upper limit of the measure of E sub n is always less than or equal to the measure of the upper limit of the set E sub n. And the second one is whether the upper limit of the mu sub E sub n, mu of E sub n is always greater than or equal to the measure of the upper limit of E sub n. So pause the video if you want to work on this problem by yourself. Okay, let's see. Now we claim both are not true. Both are not always true. By giving examples. For the first one, so first we want to recall that the definition of the upper limit of E sub n, right? This is just the definition of from n from 1 to infinity for n, and then for any let's say k greater or equal than n, and then E sub k. This is the upper limit of E sub n, right? So for the first case, let's think about like x is all the natural numbers, and then this set, measurable set, is all the subset of n, and the mu is just the counting measure. So mu of any set E is equals to the number of elements, number of in E, right? So counting all the number of elements in E, and here X is the set of all natural numbers. Now we define E sub n is just the set of all the integers greater than or equal to n plus 2 for all n in this n, right? So now in this case, what is the measure of upper limit E sub n? This is basically the measure of n from 1 to infinity, k greater than or equal than n, and then E sub k, right? E sub k. And then this is just, we can say from n to infinity, right? And the E sub k is just from the definition E sub k. This is just all the set from n plus 1, n plus 2, right? And then the intersection for all of them, because this is decreasing, intersection for all of them is actually empty set. And then the measure is 0. But each E sub n is infinity, because there are infinitely many number of E sub n. So by the counting measure, it's infinity. So this, what does it give us? The infinity. And then if you take the upper limit of this, is also infinity. This means the upper limit of mu of E sub n is strictly greater than mu of the upper limit of E sub n, right? In this case. So we give a counter example to the first statement. And then the second statement also is not always true. Now this time, we can pick X, the space, to be the unit interval from 0 to 1. And this mu is a Lebesgue measure. And then I'm just all the Lebesgue measurable set, right? So, and then we can define this E sub n to be, we just use a the closed interval from 1/2 to 1 if n is a odd number. And then another half interval if n is even, right? From this 1/2 1. So in this case, what is the upper limit of E sub n? This is just the from n equal to infinity, and then union k greater than or equal to n E sub k, right? And then because for any n, this you have you union these two parts, and then n is odd or even, and this is clearly, this set is the whole unit interval, right? So, and then if you and from 1 to infinity intersect all of them, it's just itself, right? And then so mu of the upper limit of E sub n is just the Lebesgue measure. We use mu or m, right, of this open interval Lebesgue measure, which is 1. But if you look at each individual mu of E sub n, each individual one is just half of the unit circle, a unit interval, which is 1/2. So in this case, we have this limit, upper limit of E sub n is 1, which is strictly greater than 1/2, which is the, if you take the limit, because each term is 1/2. So if you take the upper limit of mu of E sub n, which is the same, right? So this also gave a counter example of the second assertion. So that's it.